Hello guys, we want to look at Ferryman problem and Ferryman analysis, and I want you to listen. Although what is Ferryman is commonly referred to the classic application of relative velocity and vector analysis in two dimensions. So in this particular topic, we are going to be considering what we look at the application of relative velocity, and we have to look at how a swimmer or a boat can cross a river in relative to what? To the what? To the shoreline or well, whether to the river bank or thereabout. Now, let us consider something here. Let's have the river like this. Let me draw a wider diagram. Let's say this is a river and you are about to start from here and end up in this destination to move from what? From A to B. From this, let's call this one the river bank. The river bank. Now, the man will head through what? A line. This, let's say this one is the current direction. That is the current direction. Now, you can only use this when you are not giving a specific direction in the question. So, the current what? Direction of the river. Let's say the river is flowing like this towards the east. This is the river flow direction. And this is the starting point to what? To cross the river to the opposite bank. Now, let's say that you draw a line from here to this point where the what? The boat will head directly. It is to travel directly to the opposite bank. This is the direction of the what? Of the swimmer in which it will swim relative to the what? To the river or what? To the water or with respect to the water. So this is the direction. So if you want to swim with respect to the what? To the river, it will be what? This velocity directly to the opposite bank. Now, but we notice that it will swim this way at this angle. This one is what we call the VBR. What is VBR? VBR means what? It means velocity of what? Of the boat relative to the river. So, or we can call it what? We can call this direction the velocity, or we can call it velocity with which what? The boat uses to what? Uses to cross the river. To cross the river. That is velocity to which it cross the river. Sometimes we can also call it what? The velocity of the boat or swimmer in what? In still water. It is to travel directly. That is velocity of what? The boat in still water. That's what we call this velocity. Also, we check the velocity. It is moving perpendicular to the what? The current direction of the river. This is the current direction. This is the river flow. River flow in what? In this direction to the east. Now, this is what we call the what? The shoreline. The line what? That the boat will pass to cross the river. Let's call it the shoreline of the river. Of the river. And this is the bank of the river. Now we notice that what? That this particular velocity I told you is perpendicular. VBR is what? Is perpendicular to the current direction of the river. Don't forget that the boat is moving in what? Against the current of, or while the current of the river is flowing, the boat is what? Crossing the river. So while the current of the river is flowing, that means there must be current velocity of the river. We can call it the river what? Velocity, because we notice that the current direction of the river and the velocity of the river, that means the velocity of the current river and the current velocity of the river are the same, and that is its direction. We are coming there. We are going to talk about that. Now, this is a bank. I told you that what? That the velocity of the boat related to the river, or we can call, do you know that we can call this one what? Velocity of swimmer with what? Relative to the water. To water. Where water is representing the river now. Now, sometimes we say velocity of the what? Of the swimmer relative or with respect to water. That is its direction. And I told you that is what? That velocity is perpendicular to the river bank. It's also perpendicular to the river bank. I hope you know. So this is the river bank. This is the bank of the river. This is opposite bank. This line is opposite bank. So let me leave it first. So now the BR is perpendicular to the what? To the current direction of the river. Don't forget, I told you the river flows what? Eastward. I'm coming there. Flows eastward. East direction. Now, there is a shoreline, and if the boat has to move to get to the opposite bank, is that it moves directly or it moves with what? With what we call the actual velocity. This is the actual velocity where the boat will steer. This is to steer it what? In this direction, and that is the direction theta to the shoreline. So this is what we call the actual. We call it the VBS. VBS is what? Is what we call what? Is velocity of what? Of what? Boat relative to the what? To the shoreline. The shoreline. Velocity of, and you can write it as what? VBS is same thing as what? VB minus VS. Velocity of the minus velocity of the shore. It can also be written as VBR. Let's know what? A stationary point there. VBR, BRS. Let's assume that. Let's give it what? A common what? Position. The VBR, VSR. Now, but you know that VSR, this one and this one are the same. I just want to introduce something. VSR minus VSR is equal as what? Plus what? VRS. So we can write this one as what? VBR plus VRS vector equal to VBS. Now, what am I trying to relate there? It means that if here is VBS, VBR, here will be BRS. And that is what I'm going to. Now, if this one is the velocity of the boat relative to the shore, which is what? This is called VBS, the actual velocity or the actual speed of the boat or the swimmer. Boat or swimmer. We can also call it that is the velocity at which it what? Move. Don't forget, this one is going like this. This is what? Moving upward. So that means this one will be the resultant, because look at the arrow, and that's why they could form a vector relation like this. So in this case now, VRS is plus what? VBR is equal to what? VBS. So the actual speed of the boat or river, or the magnitude velocity magnitude what? Velocity, or what we call the absolute what? Velocity. We can also call it what? The velocity of the what? Of the swimmer with respect to what? To the shore. It can be called what? Velocity of the swimmer with respect to what? To the water. Can put it to the shoreline, to the water. If I assume that this is velocity of the swimmer, not even assume, because he's swimming if you swim directly to cross the what? The river. That means if they say that calculate the velocity with which it will cross the river directly, this is velocity. So the VBR is what? Velocity of what? Of crossing the what? The river. Velocity of the what? Of the swimmer or boat used to cross what? The river directly. That means without going through any direction, perpendicular, straight down. So to move straight down from what? Don't forget this is starting point. So if this is the starting point, this is the destination. You have to move directly. So if they give us the actual speed, the velocity of the boat related to river, and we are asked to find the velocity, we can actually interchange this one by bringing this one here and calculate the velocity at which the new velocity at which it move directly by taking the velocity of the boat related to the river and bring it here, then calculate the new what? Velocity at which it cross directly. So, but just know that from A to B is the velocity what? Of the swimmer or boat used to what? To cross the river directly. Okay, I think I've talked about uses the cross river directly. So that is just it. Now, if the question also say, now don't forget I told you this is the velocity of the river. Why this one is like the velocity of the swimmer? If you want to look at it that way, why this one is the velocity of the swimmer relative to the what? To the river. You want to look at it of the swimmer relative to the river. So this is velocity of the swimmer. Which is velocity in still water. Don't forget, they can say velocity in still water. This is it. Now the river velocity or the current velocity is that one. So VRS is what? The velocity of the river relative to what? To the shore. Now this is the shore. Look at the board. This is the shore. So it is moving with respect to the shoreline. Why this particular one is moving with respect to the what? To the river. This is the river, the river flowing what? Eastward. So it's moving with respect to the river because it's perpendicular to the river bank. Now, another thing again you must note that I want to emphasize on here. I told you this one can also be called what? Velocity of what? Of river or the current what? Velocity of the river. So the current velocity of the river. So the river what flows with this what? This velocity like this. That means flows with this velocity. So velocity of the river towards the east direction. Don't forget the current direction what is also flowing towards the east. Why if the person have to the velocity of the boat in still water is flowing north. Don't forget. Then the actual velocity is what? This velocity. And I told the velocity of the boat or velocity of the swimmer is what? To cross the river directly is this one. Now this is the shoreline. This is the bank. Let me call this one alpha. And let me call this one theta. So theta is angle to the shore, alpha is angle to the what? To the bank. If I draw a four-dimensional diagram here, where here is east, here is north, here is south, and here is west. automatically mean this one is equal to this, which is equal to this line, this angle, which is the shore line is always what? Let's say measure from the north, the angle to the shore, measure from the north, while the angle to the bank measure from the east. There. So in this case now, this angle here is also equal to this angle. Alternate angle are equal. Is alpha. Alpha. Now, this is the width of the river. The width of the river is width. The width of the river is it. Now, why do we need the width? We use the width to calculate the time it takes to cross from A to B. To cross the river, we use the time to what? To solve, or we use the width to solve for the time. Now, how do we use the width to solve for the time? This width is simply what? Just divide the width, or width divide by what? By the velocity in still water. So if I divide velocity in still water by the what? Or the width by the velocity in still water, you are going to have that. What I'm saying now is that the time taken to cross what? The river is equal to width divided by what? Velocity in what? In still water. That is how to calculate the time taken to cross the river directly. So that is the width is always what they measured in meter or kilometer or thereabout, but it's measured by standard in meter, can measure in kilometer. So this is the width of the river. Width. Now sometimes we can calculate the what we call the distance. How they can ask you how far down the stream will the boat land? How far down the stream will the boat land? We can also solve. Let me clean this side. I believe you have written this side now. Now we can also solve for what? The time by what? Saying how far down the stream, downstream. Now what is downstream? This is what we call the upstream. You understand me? The destination there is what we call the downstream. So the angle what to the stream, to the upstream is what? Alpha, which to the river bank. While to the what? To the shoreline is theta. So angle of the upstream to the shoreline is theta, to the downstream is alpha. And don't forget that we now will divide by velocity of current. That's what you use to solve for time. It takes the same time. Don't forget this time is also the same with what? Width divided by what? Velocity in still water. Velocity in still water. So please take note of that. Velocity in still water is the same thing. So what I want you to understand is that the velocity here is the velocity of the boat related to the river. Also is the velocity of swimmer with respect to water, or the velocity of swimmer in still water. It can also be called the velocity of the swimmer with what? Let's say with respect to the what? Okay, we can say the velocity of the what? Of the boat that he uses to cross the river, or the swimmer that he uses to cross the river directly. I think I've mentioned that several. I'm just reviewing them again. And don't forget that this line is what? Is perpendicular to the river bank. Why this river flow? This one is parallel. This one, this VB R or VRS, where is it? VRS, yeah. This line is parallel to the what? To the river bank. It's point parallel. That means it's vector line point what? It's vector point what? It's vector point what? Parallel to the what? To the river bank. river bank or to the bank of the river. So that means this one now is what? This is shoreline. It moves what? The river current or the river velocity, the velocity of the river, velocity of the current velocity of the river. Then this one is what? Velocity of the boat related to the river. Velocity is still water. The velocity it will use to cross the river directly. Velocity of the swimmer or the boat related to the river. So it can be any of these things I've mentioned. Just take note of that. And in case you see it in question, and you can in a layman, or let me say in a direct term, this is velocity of swimmer, this is velocity of river. Then the relative velocity with respect to the two of them is this one. So this is the velocity relative to the what? To the two of them. You understand me? So that is what we call VSR. So VSR. So velocity of swimmer relative to the what? To the river. So we are relating the two of them if the question comes in that way. Another way you can also relate this thing is that don't forget that the river flow I told you is flow through what? East. Why the what? The swimmer swim directly or crosses the river directly northwards. And this is the actual speed or the magnitude velocity or the magnitude speed or the absolute velocity, which can be solved by triangular. You can get the what? The magnitude of that velocity by saying, how do you get the velocity? VBS is equal to square root of what you square by Pythagoras theorem is equal to what? VBR squared plus VRS squared. Get it? Then to get the angle to the shore is what? Tan theta is equal to what? VRS over what? VBR. You can get tan theta opposite over adjacent. You can get that one. If you get your this in theta, which is equal to tan inverse of what? VRS over VBR. We can now therefore solve for what? Alpha. Alpha is what? Angle to the bank. Don't forget theta is what? Angle to the what? To the shore. To the shore is this angle. So in that case, this is what? VBR. So in that case now, this one will now be 90 minus theta will give us what? Alpha, which angle to the what? To the bank. Now, the angle to the opposite bank, just add 90 to this one. To get the angle to the opposite bank, get the shore angle, then add 180 to it, 90 to it, you get the opposite. Although, if you find the angle here, the tan of this one and tan of what you are going to have here, it's still the same thing, just that one will be having minus, the other one will be having plus. The minus indicates opposite. So this is what? This is shoreline. Don't forget this, which is parallel to this one. Okay, this was the river bank, the river, then the stream or the river flows in between like this. So that is just that. So I believe that when we solve question and you follow me when I'm solving question, I've mentioned majority of the analysis. I've told you why this one is parallel to this one. I've explained it is parallel. This one is perpendicular to the river current or the river bank. I've explained how to find the magnitude of what. Then if they wanted to find what? The velocity at which it crosses the river directly, what you just go to use now be what? We now interchange to find BR, that what? This one will now be given to this. So now be BS squared minus VRS squared. This is what? To find what? The velocity that will cross the river directly. To cross velocity, which with what? Which the swimmer crosses what? The river directly. So that is with velocity. So I believe you enjoyed it. We are going to do more and solve more questions in our next class to balance the understanding of what we have talked about concerning ferryman problem. So we are able to talk about the upstream, downstream, the bank. We talk about velocity of boat related to the river, velocity of river related to the shore, which is the velocity of the river, or velocity of current velocity of the river. We have talked about the what velocity of the what of the swimmer related to the what to the river, or the velocity of the boat related to the river, which is one perpendicular to the current um velocity or current direction of the river. So we have mentioned a lot of things, and I want you to rewatch and watch the video. You will get so many things, you get to learn so many things from it. Even from the vector derivation I did here, a lot of things will be learned from there. So ensure you subscribe and have a wonderful day. Thank you for watching.